We are live on YouTube. And what are we doing here? Let's go. Yeah.
Ooh, doggies. It's always weird after a long break when you open up your computer again. You go, what was I working on?
What was I working on?
It says I have no internet, so guess I can't go tomorrow.
We are live. TikTok.
All right.
Uh-oh. Sorry, the chat is being weird on YouTube.
Yeah.
Yeah, I'm live. One of both places.
Okay. Welcome back. Happy New Year. Happy back to school. We got lots of people joining in, so go ahead and take a look. Let's get those brains working. I know we're just going to jump right in with some polynomials and some quadratics, but why not? It's a brand new year. New year, new you. Okay, so if you have any questions about this or anything like that, or if you have the answer or answers, maybe there's more than one answer, pop it in the chat and let's get into it.
Sorry, I'm trying to get the
That's
YouTube
okay.
chat going.
Oh, Florida man Kyle. Yeah, the percentages being reversible. It's sort of crazy when you don't. I love finding out things like that are just so like, oh, yeah, that does make sense. Oh, Mac, you're already starting for finals week? We'll get into a lot of final stuff this week probably, but I'm excited to be back. I hope you're excited to be back. All right, so we got a lot of solutions here. Florida man Kyle, you know what? What is it? You're 45? Yeah. See, when we were in high school and junior high, like nobody taught us that kind of stuff. It was just whatever was in the book, right? And then do the even questions. My students get so confused when I tell them like, oh, well, the answers to all the odds are in the textbook. And they go, why is it only the odds? I'm like, because back in the day, math teachers would only assign you the even problem, so you couldn't just look up the answers. Like, we never got the answer key back in my day. Oh, Em, you got a 105 out of 100 on your math final? That's awesome. Yes, that's exactly why they did that, was because you could do the odd questions if you wanted to be able to check your answer, but the evens were the ones that the teachers always assigned, so you couldn't have the answer key. Math education has swung pretty far in the other direction for some things. I mean, there are a lot of things that are still pretty traditional and pretty kind of the same that we have, but a lot of math education has become, I try to give my students all of the answers, at least the answer key, and look for the solution. But okay, let's see. Oh, Hero Baba, I teach in Michigan. So it is very cold. There's snow on the ground. We've had snow and below freezing temps for basically the whole winter break. So, all right, let's get into this. So when we're looking at these, this is called a quadratic, okay? So we've got, and the reason we know it's a quadratic is because this variable is to the power of 2. It's squared. So that is called a quadratic. Now, since we have multiple terms, it's technically also a polynomial, but more specifically, it is a quadratic because the highest power is 2, okay? So let's see. So, God freaks, what grade math is this? This is 10th grade. Algebra 2 is usually when you really start working with these. Sometimes you'll see them in Algebra 1. It just kind of depends on the state and the standards and all of that. Okay, so what we can do with this one, so a lot of people have taken a look at this and I see a lot of correct answers, which is awesome. So when you're solving these, one of the first ways to try to figure out with these answers is it factorable? Because if it's factorable, I can factor it, which means I'm going to write it out as a multiplication problem. Because, so in order to do that, I look at what are two numbers that multiply to positive 6 and add to negative 5. So two numbers that multiply to positive 6 and add to negative 5. So what we figure out is that the two numbers that fit the bill for that are negative 3 and negative 2. So so negative 3 times negative 2 gives me positive 6. Negative 3 plus negative 2 gives me negative 5. So I can rewrite this. Those are my factors. And if I rewrite this as x minus 3 times x minus 2, this right here, if I multiply these two together, and a lot of you may remember foiling, right? If I do x times x, it gives me x squared. X times negative 2 is negative 2x. Negative 3 times x, I add those together, I get negative 5x, and then negative 3 times negative 2 is positive 6. So now I've got that these two things multiplied together are going to be 0. So there are two values now that we can see that's going to make them multiply to 0. Because if we've got however many things that we're multiplying to and they equal 0, one of these is going to have to equal 0 in order for it to multiply together to equal 0 for the whole thing. So either x minus 3 could be the one that equals 0, and that would be true, or x minus 2 could be the one that equals 0. So if x is 3, or if x is positive 2, then either one of those values are going to give me 0. So if I have 3 squared, that's 9. Negative 5 times 3 is negative 15. So 9 minus 15 is negative 6. Negative 6 plus 6 is 0. That one checks out. So 2. So 2 squared is 4. Minus 10 is negative 6 plus 6 is 0. So they both work out. So my answer to this is two answers. It's positive 2 and positive 3. You try to write your answers going from least to greatest, but you know, ultimately if you got 2 and 3, great, you're done. Okay? All right, so that is factoring a polynomial and solving a quadratic using factoring. Okay, really straightforward, one of my favorite things. Let's see. Okay, so over on YouTube, let's see, we've got, is polynomial a middle school level in the US? In Singapore, we introduced them at 4th grade. Wow, 4th grade. So polynomials like this are typically not introduced until, in the US, I would say probably the earliest is probably like 8th grade. Now I'm talking about like in kind of like a regular level classroom, right? Now, if you've got honors or accelerated or something like that, of course, you're gonna see them earlier. But typically, the earliest you would even really see it is like 8th grade. Why is it in brackets? Oh, so down here, so we use these are called curly braces. We use these when we're making a list or a set of values, because if I have more than one solution, okay, if I just listed these as 2, 3 in parentheses, it would look like a coordinate point, which it's not, right? It's the 2 and the 3, because what this actually represents is where, if I were to graph it, the parabola would go like this. It's gonna cross at 2 and 3 on the x-axis. So again, this is usually, I mean, really in the US, it's typically anywhere from 8th grade at the very earliest, I would say. But primarily you focus on these in 10th grade. So like, for example, I'm gonna be working on these with a lot of my students pretty much like after we take our finals in a couple weeks. We'll be working for primarily the rest of the year on these types of things. So let's see. Okay, let's see. Tommy, let me see what your equation is. What was your equation? Yeah, so Tommy, so you're doing the quadratic equation, which would absolutely work for this. However, so let's talk about this. So with the quadratic equation, so this is just the tip of the iceberg for quadratics. Quadratics get so much more complicated pretty quickly. But Tommy, what you brought up is the quadratic equation, or the quadratic formula, sorry, where we have, so ax squared plus bx plus c equals 0. So this equation up here that I gave you is in this standard form. It's equal to 0. My a value is 1. My b value is -5. And my c value is +6. So the quadratic formula you can use to solve any quadratic equation, but it's not always the best choice, okay? It does always work, okay? And the quadratic formula, sing it with me, is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so I can use this to solve this equation, okay? But here's what it's gonna look like, okay? It's gonna be, I'm gonna do this. Okay, so to use the quadratic equation to solve for this, I would have x equals -b, which is gonna be -5, so that's 5, plus or minus the square root of b squared, which is 25, minus 4 times 1 times 6 over 2. Now, you will eventually get to your solution of 2 and 3. This is not a great choice for this problem. This is way more confusing than doing the factoring. So that's why I always tell my students to check if it is factorable, especially if a is 1. If a is 1 right here, it's so much easier to determine if it's factorable because you're just looking at that and that, what multiplies to that and adds to that. Because I'm gonna have to go through and I'm gonna have to simplify this and work your way down and all of that kind of stuff, when you could also just factor it and see that, oh, it's just 3 and 2, or 2 and 3. Okay. All right, so Ellie Grace, what are you confused about? We're working through some quadratics. Now, if you haven't seen these before, don't worry about it. Okay, it's okay. All right, but so we're comparing, looking at this quadratic equation and solving it by factoring or using the quadratic formula. So again, so the quadratic formula will work for every single problem. Every single quadratic, you can use a quadratic formula, but it's not always the best choice. Okay, sometimes factoring is the easiest. Sometimes completing the square is the easiest. Quadratic formula always works, but it's not always the number one choice. Okay, so those of you who are just joining us, welcome. We are typically live on Thursdays, but I thought we might want to do, you know, a little maybe Sunday scaries. Those of you who are going back to school this week, things like that, that you might be a little bit worried about it, all of that kind of stuff. Yeah, so my song of joy and nothing to know. This is basically the AC method, is just the factoring, right? So this is the factoring method and things like that you can work on, okay? All right, so those of you who are just joining us again, so we typically we work through, you know, pre-algebra through like algebra 2, maybe into some trig and pre-calc stuff. So if you have anything coming up, some of you may be going back tomorrow to final exams or getting ready to do final exams, right? Like I know we've got our finals in 2 or 3 weeks. Oh, Keanu, I can do the slide and divide method. Yeah. So let's stick with quadratics. Let's keep going with this. Let me do. Okay. Let's see. Okay, now that my computer is all up. Okay, so now the thing is that with the, so here we go, okay. So slide and divide, this is also kind of like the AC method. I'm gonna put these off to the side. Okay, so let's get a little more complicated with this. Okay, let's do 3x squared minus 17x equals negative 10. Okay. So if you're given this one, how would you go about it? There you go. All right, blue dot, let me know if you can't see it still. I moved it down a little bit. Okay, so everybody's catching on that the first thing we need to do is add that 10, right? So regardless, when I look at this problem, okay, I'm first going to make it equal to 0 by adding 10 to both sides. So now what I'm looking at is 3x squared minus 17x plus 10. So now I've got it in this nice trinomial. Trinomial means, tri means 3. So we've got 3 terms, right? So now we've got it in the ax squared plus bx plus c equals 0 form. So I could do quadratic formula with this, okay? I could, but I'm also going to double check because, you know, quadratic formula gets messy. The quadratic equation, it gets messy. So I'm gonna first see if I can factor this. So remember what we said on the last one is that when a is 1, it's really straightforward. It's multiply to this, it's add to this, and then you're off. But in this case, since this one is here, okay, what I'm gonna do is I'm gonna actually slide this 3 down here. Okay, now this is a shortcut. Okay, this is a shortcut. This is kind of a trick. Okay. So if I do that, now what I'm looking at is x squared minus 17x plus 30 equals 0. Okay, so looking at that, now let's see if I can factor it. So now that I've got 1 there, what multiplies to 30 and adds to negative 17? What's that small to? Oh, that's squared. So that's x squared. So Peanut, actually, one is this one is negative and this one is positive. Now, what shows me that they're actually going to be the same sign. But that's a really good observation that you're kind of thinking like, one's negative, one's positive. So the fact that the C value is positive, that means that the signs of the factors will be the same. They're either both going to be positive or both going to be negative. Because two positives multiplied together equals a positive, and two negatives multiplied together equals a positive. This sign tells me what those are. So they're the same and they're both negative. So now when we're looking at things, right? So I see a couple of you have got this. So we've got what multiplies to positive 30 and adds to negative 17. And that, my friends, is negative 15 and negative 2. So I can write this as x minus 15 times x minus 2. Okay. So now I have factored that, but if I multiply these back together, they don't give me this, right? I'm missing that 3. This would just give me x squared. So what I have to do now is I have to divide by 3. So I did 3 times 10 down there. Now I've got to kind of undo that. Remember, this is a trick, right? This is just a little trick. So I'm going to divide both of these by that 3. So now negative 15 divided by 3, this one's going to be x minus 5. Okay. This part's a little bit weird, okay? It's x minus 2/3, because 2 can't be evenly divided by 3. So this 3, I'm trying to think how I want to explain. Yeah, I guess we'll just do that. This 3 kind of goes up here and goes in front of that x, and then that 2 drops down. So again, it's just a trick. Okay, this slide and divide, bottoms up, there we go, right? So whatever's on the bottom, it goes up, okay, bottoms up. So 3x minus 2. Now, if I multiply these two together, I will end up with my original quadratic. Yeah, my song of joy. I never really did this one because I don't mind teaching my students like shortcuts, right? We're like, and then all of this noise, then we can just go on to that. I don't really like teaching them tricks, and this one is just sort of a trick that you can do. I don't know. I'd like to hear how other math teachers feel about this slide and divide method, because, ultimately, like, as long as your students understand the concept behind factoring, you can get there, right? So now we've got this solution where, again, we've got either x minus 5 is the one that's going to equal to 0. So if x minus 5 equals 0, the whole thing is going to be true. Or 3x minus 2 equals 0, and then the whole thing will be true. So if x equals 5, that's going to work. Or here I would plus 2. So then I have 3x equals 2. And then divide by 3. So x would be 2/3. And I'm going kind of fast through that. Okay, so my solutions here, we've got our curly braces because we're going to list our solutions, 2/3 and 5. So these are both my solutions. I could do quadratic formula. You could go all the way back up here, and you could work with a quadratic formula where you would do x equals 17 plus or minus a square root of 17 squared minus 4 times 3 times. That's a lot of big numbers when you can also just slide that and then it's factorable. And these are all things that you can check, and I always recommend checking things recommend checking to see, is it factorable? Because quadratic formula, you can always just put it in, right? You find the discriminant, you can always just put it into your calculator and move on. But this is, yeah, these are quadratic equations or polynomials. Typically, you learn this in like Algebra 1 or Algebra 2. So like 9th or 10th grade, it just depends on your school and the pathway and stuff like that. Ooh, your first Calc 2 lecture tomorrow. You know, Jacob, how did you feel in Calc 1? For me, my biggest like pinch point in my math career was like pre-calc. I had a really hard time getting past pre-calc. And then once I got over the hump of pre-calc and trig was just not clicking with me, then the rest of all my calc classes were fine. Once I got through Calc 1, Calc 2, like the next 3 or 4 years of calc that I took were just fine. But, you know, it just depends. Wait, my song of joy, I'm not understanding your question. How this trick works is not to divide the B. You leave the B alone. You just do A times C, which you do in the AC method, right? So you would do that. So the other way to do this would be the AC method, where you would find your -15 and -2, and then you would split the middle, right? And then you would factor out the 3x, you would factor out the, what would you factor out? The -2, right? So you can do all of that. And then, yeah, and then, so it's the same thing as long as you didn't, as long as you don't multiply by the B value, yeah. Ooh, Donovan, what class are you in? Can we help? I don't know. It's gonna be tough to help if you're in calculus. Yeah, so this is typically 9th or 10th grade, maybe 8th grade. I don't know, somebody was saying in Singapore it's 4th grade. But yeah, this is, here we are. Okay. Oh, Donovan, Algebra 2 honors. Gimme the Algebra 2. Okay, let's get you ready for this, for your final this week. I've taught Algebra 2 and Algebra 2 honors for many years. Let's do it. I love Algebra 2. Well, hopefully that kind of helped, though. Actually, the quadratics, I would assume, probably helped you a little bit at least. But all right, so guys, those of you who are just joining us, you know, come on in. If you've got a question or a specific concept that you want to go over, let me know. Let's get into it. Maybe you have finals this week. Woo, having finals this week, first week back. That's tough. My high school might have done that. We have 2 weeks back and then we have finals like that 3rd week in January. So yep, so slide and divide or slip and divide. Yeah, that's what we just did. Yeah, slide, divide, bottoms up. I know some people aren't even going back to school until next week. Like, I know there's a couple of districts in Texas that aren't going back until like the 12th. Do not stay up until 1 a.m. on a school night. That's a terrible idea. It's a terrible idea. All right, so let's see. Similar triangle. Not 2 a.m. Wrong direction. Okay, similar triangles. It's 2 a.m. in Germany right now. Woo! Are you going to school tomorrow, or I guess today? Oh my gosh, period. Teach me biochemistry. Are you saying that just because you know that that was my major? I love biochemistry. If you have a specific question about biochemistry, I will get into it. Okay, but we've got similar triangles. So when we talk about similar figures, similar in like the mathematical sense means congruent angles and proportional sides. Okay. Now, if these two angles are congruent, right? Well, this angle is congruent to this angle, and this angle is congruent to this angle. Then we know that that angle has to be congruent to this one, okay? Because they have to add up to 180. There we go. Lazy Penguin, I teach primarily 10th grade. Yeah, I teach primarily 10th grade. Some 9th graders, some 11th graders, just high school in general. So now the angles are going to be equal, but the sides are going to be proportional, okay? So proportional would mean that if this is 4 and this is 8, then let's say if this is 10, what would this one be? Okay, we have 4 to 8, and then 10, and we don't know what. And then what if this one was 18? And this one we said is y. Okay, so let's figure out what would be x and y. So x is 20, y is 9. And what would be the scale factor? Going from A to B. Nice. Okay, so our scale factor is 2, right? Going from A to B would be 2 because we're multiplying everything by 2. So x, since this side is 10 and this side is x, right? 10 times 2 is 20. Here, what times 2 is 18? Well, y is 9. Okay. And so this is ultimately, you know, the corresponding parts are going to be either congruent if they're the angle, or they're going to be proportional if they're the side lengths. Okay. Okay, let's see. Oh, why is that giving me that? Oh, Lordy. Hold on, I'm having computer issues. Issues. This is what happens when you don't open your computer for 2 weeks. Okay. Ooh. Ooh. This one looks fun. Okay. I don't know. I just found this problem online. Let's try it. I have no idea what the answer is going to be. All right. Let's see. I don't know if we're going to have to get into trig or quadratics or whatever, but we've got a right triangle here, and we've got a person standing here. Let's see. We've got A, E, D, B, C. Okay, so usually a question like this is like a person is standing with a light post, right? And they're casting, their shadow is ending at the same spot. And that person is standing, let's say 30 feet from there. The height of the lamppost is, well, the height of the person is X. The height of the lamppost is 3 times X plus 6. And then this distance here is 2x minus 2. So let's figure out how tall is the person. Okay, so we'll go x equals question mark. Okay, so let's see. Okay, I'll give you guys some time to do this. So this is still with similar triangles. Okay. So you can do this and you can set up a proportion. Sorry. Zach, we don't really get into differential equations in here, but if you have a specific question or something like that, put it in the chat because we've got a great community here who can help you out with that. Oh, I had a little blip in our connection. It's a 30, 30, 60 triangle. I don't know if we can come to that conclusion with it being a 30, 30, 60. Plus a 30, 30, 60 triangle doesn't even work. 30, 60, 90 would work? Okay. Oh, we don't have enough info. Well, let's go ahead and let's look at this. So we can break this up into two similar triangles. You know, we know they're similar triangles because this is a 90 and this is a, it's a person standing straight up, so it's a 90 degree. And then we've got this angle for this smaller triangle is the same as this angle in this larger triangle. So they are similar triangles. So we're going to set up a proportion, okay? And what we're going to be looking at is I'm going to do the height over the shadow length. Okay, so the height over the shadow length for the red triangle would be x over 2x minus 2. Now, I could do shadow length over height. I could do height over height and shadow length over shadow length, but I'm just setting it up this way to start with, okay? So now I'm going to do, for my other triangle, I'm going to do my height over my shadow length. Now my shadow length here is a little bit complicated because it's tempting to just do over 30, but it's not just 30. It's 30 plus 2x minus 2. So that is my proportion that I'm going to now solve. Let's get into it. Okay. Like I said, guys, I just found this problem. I don't know what it's going to be like. So let's look at this. So I'm going to go ahead. I'm going to rewrite my proportion down here. So I've got x over 2x minus 2. And I'm going to simplify this a little bit where I've got 3x plus 6 over 2x plus 28. Okay. To solve a proportion, I cross multiply. So I'm going to multiply here and I'm going to multiply here. So I've got x times 2x plus 28. And when I do these cross products, they equal each other. So then I've got 2x minus 2 times 3x plus 6. So far, so good. Okay. Oh, thanks, Mateus. Can't read. Okay, so I've got 2x squared plus 28x equals, this is looking like a quadratic, 6x squared, so that's my first two terms. I've got plus 12x. I'm going to write it all out for those of you following at home. Minus 6x, negative 2 times 3x, minus 12. I'm going to simplify down. 2x squared plus 28x equals 6x squared plus 6x minus 12. All right, so now I need to get everything onto one side because I want it to be equal to 0. So this will be, I'm just going to move everything over here by subtracting it over here. KB, put the answer in the chat. Let's do it. Okay. So we have negative 4x squared plus 22x plus 12 equals 0. Now what I'm going to do is I don't want to have this as a negative. So I'm going to go ahead. Oh, and actually everything's divisible by 2. So I'm going to divide everything by negative 2. Both sides. Oh my goodness, this is a 3-board problem. Holy moly. We are starting off the year with a 3-board problem. Okay. Ooh, so negative 6 and 1/2. So KB, which one would it be? All right, so we're going to divide everything by negative 2. Let's see. So we've got 2x squared minus 11x minus 6 equals 0. All right, so now I'm always going to double check. Can I factor this, right? So 2 times negative 6. So I'm going to do my slide and divide trick that we learned, right? So I'm going to slide that 2. So I've got x squared minus 11x minus 12 equals 0. Okay, now what multiplies to negative 12 and adds to negative 11? That's going to be negative 12 and positive 1. Okay, so we've got x minus 12 and x plus 1 equals 0. Okay, and now I've got to, remember up here we slide, now we divide. We're going to divide by that 2 again. Oh, Picto, how can I get that negative 2 in the denominator? Everything's divisible by 2. I want to get rid of that negative because you don't want to have a negative as your a value. So you can just write, you can just divide everything by negative 2. Okay, this is factorization. Now KB, go back and double check your stuff. Okay, so I think you might have gotten your symbols mixed up. Okay, so we've got x minus 12 divided by 2, so that gives me x minus 6. And then remember bottoms up, so times 2x plus 1 equals 0. So I'm going to split these. I've got x minus 6 equals 0, and I've got 2x plus 1 equals 0. So my solutions are actually x equals positive 6 or x equals negative 1/2. So KB, I think you just got your symbols mixed up or something somewhere. Negative 1/2 and 6. So when we go back to thinking about our actual problem, right, we go back to what we are looking at, which we are trying to figure out the height of this person. It can't be negative 1/2, right? It's got to be the positive 6. That's it. Oh, that was a good one. We got quadratics. We got similar triangles, all that good stuff. Now, even though this one did get very complex with using a quadratic to solve it, the concept is still the same. Even if this were like, 10 here or something like that, you could still figure it out based on just the numbers and cross multiplying, right? Yeah. Drop another question. Ooh, okay. All right, so let's find another challenging question. Yes, that one was fun. Okay. Oh man, do we want to do geometry questions? Oh, Nate, we can definitely do Pythagorean theorem. Okay. So Donovan, you have been asking for this one. Okay, so solve by factoring. Okay, let me write this down. Because I think what you're going to have to do is solving by factoring, you're going to have to solve it by grouping. Yeah, guys, you can always go over to the YouTube channel and you can rewind it and watch from the very beginning and things like that. Okay, so 3x cubed plus 4x squared equals 12x plus 16. So that's what you're looking at, right? Okay. All right, so here we've got some polynomials, right? We've got this polynomial equation, and you're just having to solve it by factoring. Okay, and then Nate, we will do Pythagorean theorem after this, okay? All right, but Donovan has been very, very patient. Okay, so the same idea still applies, that we want this to be equal to 0, because especially if we're supposed to solve by factoring, that means we've got to have it written out as multiplication, and that's got to equal 0, otherwise we can't do anything with it. So I'm going to subtract everything from this side and move it over here so it equals to 0. So that's going to give me 3x cubed plus 4x squared minus 12x minus 16 equals 0. All right, so now what I can do is I can factor this, but I can't do like the AC method, right? Because it's not a trinomial. But I can do something else called factoring by grouping, hopefully, as long as it's factorable, which looking at it, we should be okay. All right. So factoring by grouping is when you have 4 terms. So I've got one term is 3x cubed, the other term is 4x squared, the next term is negative 12x, and then negative 16. So these are 4 terms. I'm going to factor by grouping. I'm going to split this into 2 things that I'm going to look at. I'm going to use, I don't have a ton of different colors, but I'm going to use at least 2 different colors for these. Okay, so, and what I'm going to do is I'm going to pull out the GCF from each of the groups. So I'm looking at this half. So 3x cubed plus 4x. I can get an x squared out of both of those. So that's what I'm going to do. I'm going to pull out an x squared, and what's left behind is 3x plus 4. Okay, so x squared times 3x plus 4. Now over here with this negative 12x minus 16, since that first term is negative, I'm going to factor out a negative. Okay, I'm going to do negative 4. And that's going to give me, what's left behind is 3x plus 4. If you notice, these are the same. So now I can factor it again. And I have, I can factor it out again. So I can factor out that 3x plus 4 and the x squared minus 4. Sorry, these all equal 0 still. So now what I've got is I've got x squared minus 4 times 3x plus 4 equals 0. Now going from here to here can sometimes be a little bit tricky. So they do have to be the same. So what has to happen is when you're factoring by grouping, what's left behind here needs to be the same, right? This 3x plus 4 and this 3x plus 4, they have to be the same thing. If they're not, double check your GCFs to try to make them the same. But if you can't make them the same, then it's not factorable. Okay. All right. Yep, so now we have this. So now we know that 3x plus 4 is good. So now based on everything else that we did, right? We now know that we've got either x squared minus 4 is the one that equals 0, or 3x plus 4 is the one that would be equal 0, right? If x squared minus 4 equals 0, and 3x plus 4 equals 0, then those are two solutions, right? Now, x squared minus 4 equals 0. X squared minus 4, so if this were another trinomial, which it happens, okay, that's okay. You would still just solve it by factoring, right? Because you're going to have x squared minus 4 equals 0. Okay, well, I just go on from here, right? But what I can do is I can get x squared equals positive 4, and then I can take the square root of both sides. So x equals plus or minus 2. Because the square root of 4 is positive 2 or negative 2. And then over here, I would subtract 4. So I have 3x equals negative 4, and then divide by 3, divide by 3. So x equals negative 4 over 3. So my solutions for this would be negative 2, negative 4 over 3, if you want to go with the least to greatest, and then positive 2. So that's giving me 3 solutions, 3 roots, if you will. Okay, and that's how we would do that. Easy peasy, right? Yep, so it's negative 2, positive 2, negative 4/3. Okay. So it has 3 roots if you look up here because it started out to the 3rd power. It has 3 roots because it has 3 roots, but you can also see that it's possible to have 3 roots because of that to the 3rd power there. Okay, yeah, it's a cubic polynomial. That means it has 3 possible roots. Okay. All right, so Pythagorean theorem, Nate. Nate's been very patient about Pythagorean theorem. So the Pythagorean theorem is only usable with right triangles. So what is true is with the Pythagorean theorem, or with the right triangle, we have 2 legs that make that right angle, okay? 2 legs that make that right angle. Then this 3rd leg, the longest leg, the leg that's always across from the 90-degree angle, is called the hypotenuse. Okay, now what's interesting that Mr. Pythagoras realized, or at least he's credited with that, who knows who actually discovered it, is that if you add up the squares of both of the legs, so you square the value of the leg and you square the value of the leg and you add those together, you get the same value as the square of the hypotenuse. Okay, so you could have, we could have, there's things called Pythagorean triples. Okay, and triples are good. Okay, we've got 3, 4, and 5. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. 5 squared is 25. Okay, that's always going to be true. So if it is a right triangle, leg squared plus leg squared equals the hypotenuse squared. Now, a lot of times in geometry, you talk about the converse of a theorem, okay? So talking about the converse, the Pythagorean theorem means if it's a right triangle, a squared plus b squared equals c squared. The converse of that is if a squared plus b squared equals c squared, then it is a right triangle. Okay. Now we typically do use A and B, but the problem with that is that it's not always going to be labeled as A, B, and C. So that's why I've kind of moved away from saying A squared plus B squared equals C squared, even though that's what everybody knows. saying that it's the legs and the hypotenuse because maybe this leg is labeled as side C, especially when you're dealing with trig. When you're dealing with trigonometry, a lot of times the hypotenuse is not going to be labeled as side C. There might be one of the legs that's labeled as side C, and then people are like, "Blah!" Okay? Yes, so using the squares, using the area, like those are great ways to kind of like prove, support, defend the Pythagorean theorems, things like that, okay? But remember, it works both ways, right? So if it's a right triangle, Pythagorean theorem is true. If the Pythagorean theorem is true, then it's a right triangle. So it's the converse, okay? So that's what they are. So if we were to look at a triangle, okay, oof. We've been using a lot of boards tonight, guys. We are into the depths of my board collection. Yikes. All right, bye, Mateus. Thanks for joining us. Okay. So this triangle here. So if I've got, I don't know, 10 and 7 and X. Okay. So let's solve for X. I got root 51. Yep, so Nate, that's exactly how you would set it up. So we would set it up as 7 squared plus x squared equals 10 squared. So I'm going to go ahead and I'm going to simplify the ones that I can. So 7 squared is 49. And 10 squared is 100. So when I subtract 49, because I still want to get x by itself, right? So that means I've got x squared equals 51. So then I would take the square root of both sides, and that would give me that side length just by itself. So that's going to be root 51, or square root of 51, which if you're just learning Pythagorean theorem, you're probably going to simplify it down, or like round it, right? So root 51 is about 7.14. And that side length does make sense because that 10 should be the longest length. Okay, so 7.14 looks about right, right? It's less than 10, which is great. Okay. You can also, so this is one of those times where I do like showing my students, not when they're first learning Pythagorean theorem, but oftentimes like when we're getting into trig or more advanced like algebra 2, that kind of stuff, especially with the SAT, I usually show them like the shortcut with your calculator. So you can put this, if I'm solving for one of the legs, right? One of the legs by itself would be the square root of the hypotenuse squared minus that other leg squared. So in that case, I would just type into my calculator, it's the square root of 10 squared minus 7 squared. And that's going to give you root 51, which is 7.14. So it's just a shortcut. It's not a trick or anything like that. That's what a shortcut is, right? It's not a trick. That's still what it is, but it's a shortcut, just that calculator skill. If you want to have that by yourself, so you can just type that right into your calculator and be done. All right, guys. So it is about that time. So good luck tomorrow, all of you going back to school tomorrow. I'm going back to school, be there bright and early. But yeah, thanks for joining us. We'll probably do some more Sunday Scaries lives, especially those of you who are getting into finals. Good luck this week back, and Happy New Year.